What's up, everybody? It's been a long time since I made a video, so I wanted to give a quick life update. I have started with a new company since the last video I made. I got licensed in the state of Texas as a professional surveyor, so that's really exciting. And I have also been helping out with an SIT study group at my company now, and I've helped out and gotten 2 techs of ours as licensed as an SIT in the state of Texas. And hopefully that number will continue to grow. We haven't been at it that long, so that's why it's kind of low right now. But anyway, let's hop into it. We're gonna start off with some NCEES practice exams again, and let's just do we're gonna replicate number 39 today. All right, I am going to do this one with y'all instead of on my tablet. That way y'all can see everything that I do and I can explain it all. So, question. A total station is set up 5.20 feet above a benchmark that has an elevation of 617.5 feet. A slope angle and slope distance of 4 degrees 25 minutes and 319.78 feet respectively are measured to a reflector setup 4.85 feet above a hub at point B. Neglecting curvature and refraction, the elevation in feet of the hub at point B is most nearly one of these answer choices. All right, so write down our givens here. So we're going to look at the elevation of the benchmark is equal to 617.50 feet, 617.5. Our theta, our angle, is equal to 4 degrees 25 minutes. Our slope distance is equal to 319.78 feet. The height of our total station is equal to 5.20 feet. And the height of the reflector is equal to 4.85 feet. All right, I'm gonna draw something and just kind of put this out there. Surveying is basically always triangles, right? That's what we always solve for. So one of the things we need to remember is our SOHCAHTOA. Most important thing in all of surveying, SOHCAHTOA, sine, cosine, tangent. So let's draw this out. So I'm gonna go just right down here. I've got a ground elevation with a total station. Let's see, so this right here is the elevation of the benchmark. This right here is the height of the total station. I'm just going to draw a flat line out, just like that. And we have a positive theta, positive angle, so I know we're going up. So I'm going to draw a reflector over here. I'm going to make my ground, and we have a reflector. Okay, and I'm going to fake in this line so that we can kind of see what we're working with. This is the elevation of the reflector, which is what we are solving for. This is the height of the reflector. This is our slope distance, and this angle right here is our angle, our slope angle. So we have all of that. We need the elevation of our total station here. So elevation of the total station is equal to the elevation of the benchmark plus the height of the total station. Okay, so elevation is equal to, this is 617.50 plus 5.2. All right, got our calculator here. Go ahead and do that math. So 617.5 and 5.2. So we're looking at 622.70 feet. Okay. The next thing we need to do is convert our 4 degrees 25 minutes to a decimal. I have a fancy dance calculator, but how you would do this is you would take 4 degrees plus or I guess it'd be 4 degrees point, and this would be 25 over 60. So that would be 4.25, and I'm just gonna go ahead and do that. So that'd be 4167 degrees. So 25 over 60 is equal to 0.4167. All right, now let's draw our triangle for SOHCAHTOA, which is basically this dashed triangle right here. That's essentially all it is. I'm just gonna draw it out completely so that we know what we're working with. All right, so this is our theta, which is equal to 4 degrees, 25 seconds. This is 319.78 feet. This is just our level ground, and this is our other side. This is our height from our total station to our reflector, which is what we need to solve for. This is what we're solving for here, which is equal to the opposite of this angle here. So in our SOHCAHTOA, I'm going to use sine for opposite over hypotenuse, because we have a hypotenuse and we're solving for the opposite. So let's get that down a little bit. All right. So let's go with sine theta is equal to op over hypotenuse, opposite over hypotenuse. So sine of 4.4167. That comes from right up there. Fix that a little bit. Right there. Is equal to our opposite, which is what we're solving for, over 319.78. Okay. This is equal to, so our opposite is equal to 319.78 times the sine of 4.4167. That means our opposite is equal to 319.78 multiplied by, so I've got that, and I'm going to run a sine times 0.077. So that means our opposite is equal to 319.78, multiply that, 24.63. Okay, that'll be feet. All right, so then what we're looking for is the elevation of the reflector right there. So come over here. So elevation of a reflector is equal to, we have the elevation of the total station. We solved for that up here, plus this opposite number right here that we solved for in our triangle. So our elevation of the reflector is equal to, again, our 622.70 plus our 24.63, which means the Z or the reflector, or the elevation of the reflector is 622.7, 24.63, 647.33. Now we're not done, because this elevation here is equal to the elevation at the reflector. So what we need to do now to get our elevation right here, so the elevation of the ground is equal to the elevation of the reflector minus the height of the reflector. That is our last step. A lot of people get tripped up right here, stop right there and call it good. No, they're asking for the elevation of the hub. So you have not the elevation of the reflector, the elevation of the hub. So then our elevation of the ground, or I guess let's call it the hub, is equal to the Z of the reflector. So elevation of the reflector is 647.33 minus the height of the reflector, which we know is 4.85 from the question. 647.33 minus 4.85 off from the question. So the elevation of our hub is equal to, do my calculations here, 4.85 minus 642.48 feet. And that is our answer. So if we come back up here, we have to see that C is the correct answer. Hope that makes sense. Quick note, I know in the problem, the angle is a negative. If that's the case, then in your triangle here, you would just, instead of going up, you would go down, and you would go down. That'd be your negative. And then what you would do is you would actually, in here, you would 622.7 minus 24.63. So you would subtract the elevation of your reflector, or to get the elevation of your reflector, you would subtract the height of the distance between your total station reflector from your elevation of your total station, because you'd be going down in real world instead of up. So you would subtract these here, and again you would still subtract here, down here for your hub elevation, because you're going down from the reflector to get to the hub. So that's a quick note. I swapped it on you. So anyway, hope that makes sense. Hope you enjoyed the video. Be sure to subscribe. Thanks.